Hello, Algebra 2 students. This is a lesson on section 8.04, multiplying matrices by other matrices. I will go through this do now just because it has to do with some earlier sections in Unit 8, but it's asking us to add matrix C with matrix A. So remember, when we're adding or subtracting matrices, we have to have the same dimensions, and dimensions are rows by columns. So matrix A has 2 rows and 2 columns, so it's a 2 by 2. Its dimensions are 2 by 2. Matrix B has 2 rows and 3 columns, so its dimensions are 2 by 3. And matrix C has 2 rows and 3 columns, so matrix C has the same dimensions as matrix B, which would be 2 by 3, rows by columns. So the warm-up is asking you to add C, matrix C with matrix A, and that is not possible because matrix C has dimensions of 2 by 3 and matrix A has dimensions of 2 by 2. So we cannot add or subtract matrices unless they have exactly the same dimensions. So on this one, I'm going to have to choose not possible. Sometimes your OHS might say not defined or undefined, meaning we just can't do it. All right. This is our week at a glance. We're in the middle of Unit 8. This is a built-in unit into your OHS because Stride or K-12 or Alva Company does not include matrices, but it is in the Alabama Course of Study for Algebra 2. And then Friday we have a catch-up day. Also at the top, I know this is happening this week. You should be getting some information from your homeroom teachers or someone acting for your homeroom teacher to let you know that we have started EOY, end of year testing. This is only for 9th, 10th, and 11th graders. We are testing, I think we're testing Tuesday, Wednesday, and Friday this week. So it should show up on your schedule. And then if you can't attend, you will be scheduled for a makeup. So my advice is to, if you're not 10th or 11th grader, come to that testing as soon as possible and get it out of the way so we don't have to keep asking you to do it. It is through Neuro, so you don't have to be anywhere in person. We do this 3 times a year. It's the STAR 360 testing, and it's reading and math. We're getting super, super, super close to that May the 16th deadline for our graduation, not deadline. For our seniors, we're so excited that you are approaching graduation day. My advice to you is to continue to work daily. Seniors have earlier closing dates than everyone else. Seniors, TGAs close on April the 30th, and your CGAs close on May the 2nd. That's seniors only. If you're not a senior, so if you're not the 10th or 11th graders, your TGAs will go away on May the 13th. That's when they will close, and your CGAs will close on May the 15th. All right. We're going to skip this since I'm recording. Just a quick reminder that a matrix is a rectangular table of numbers arranged in rows, which go left to right, and columns, which go up and down. Dimensions, we've already talked about this in our do now, is rows by columns. Remember, I always think about the cheap soda called RC Cola. You can think of remote control, whatever, however you want to remember. It's rows first and then columns. This particular matrix has 2 rows and 3 columns, so its dimensions would be a 2 by 3. All right, when we're multiplying, totally different than adding and subtracting. Adding and subtracting is much simpler than multiplying. So multiplying actually comes from, it's otherworldly. It's like, you're going to go, who in the world decided to multiply matrices this way? Well, it says in order for matrix multiplication to be defined, so in order for you to be able to multiply 2 matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So I get that, but when I look at this is just easier to me. So this is my first matrix. It's being multiplied by my second matrix. So this is the columns, rows by columns. So if we do R by C, I'll show you how they wrote the definition. And then again, this is rows by columns. So the number of columns in the first matrix have to be the same as the number of rows in the second matrix. What I do is I write their dimensions down, and these two inside dimensions have to be the same in order for the product to be defined. So in order for you to be able to multiply. So for example, if I had a 2 by 3 and I was trying to multiply that with a 3 by 4, again, these two numbers have to be the same. So this would be a yes. We would be able to multiply those together. So if I had a, let's say a 1 by 2, and I was trying to multiply that with a, let's say another 1 by 2. Even though we can add and subtract two matrices with the same dimensions, unless these two numbers are the same, this will be a no or a not defined. So the two middle numbers have to be the same. So I think what we're going to look at here, it says to see why this is the case, consider the following. So matrix A has 3 rows and 2 columns. Matrix B has 2 rows and 4 columns. So it would be possible to multiply these. And I promise the way that you multiply is extremely unusual. So if you were having trouble with that and you didn't actually read through the OHS and see how to multiply, then you're probably struggling with this section. So these first few questions are just saying, do you know whether yes, you can multiply or no, you can't. So again, you want to look at the dimensions. There's 3 rows, 2 columns. So matrix A has the dimensions of 3 by 2. Matrix B has 2 rows and 2 columns. And so as long as these two numbers are the same, you're going to say yes. The two inside dimensions, the number of columns in the first matrix have to be the same as the number of rows in the second matrix. Same question here, different matrices. So let's look at the dimensions. This is 2 rows, 4 columns. This is 2 rows, 3 columns. So 4 is not the same as 2, so we could not multiply those. It's not possible. It's not defined. It's undefined. All right, this one's just giving us the dimensions. So would it be possible to multiply 4 by 2 times a 2 by 3? As long as these inside dimensions are the same, then we can multiply them. So we're going to say yes. Okay, so I attempted to find a pretty decent graphic where you could kind of see how to multiply. But honestly, I would not understand this unless I just watched somebody multiply them. So you're always going to start with the first row in the first matrix. And you're always going to multiply that first row times the first column in the second matrix. Always. It's always the first row in the first matrix times the first column in the second matrix. So if you'll look at this says A1 times A2. So that's this is A1 times A2 plus, because once you multiply one row times one column, you're going to combine all the products you get into one number. And then you're going to do B1 times C2. So this is B1, C2. And then you'll combine those. So a lot of times I'll put parentheses around here. And then you'll take this first row again, and you'll multiply that times the second column. Still on first row, and then we'll multiply it times the second column. So look at this. This is A1 times B2. This is A1 times B2 plus, because you're always combining the products, and then B1 times D2. So this is B1 times D2. And then you'll combine that. When you are finished multiplying the first row in the first matrix times all the columns in the second matrix, then you move down to the next row in the first matrix. So it's always, you take the rows in the first matrix and you multiply them by the columns in the second matrix. So then you take your second row, in the first matrix. So now we're down to the second row. We're writing our answers in the second row of our product here, our big product. And so we're doing second row times first column. And that's going to be C1 times A2, C1 times A2, D1 times C2. And then we'll add those together. Then you'll keep that second row again, and you'll move to the next column. So you'll move to this column. So it's C1 times B2, and then D1 times D2. And then you'll add those. And then you'll simplify. All right. Once you get the hang of it, it's just so different. I can't think of anything I've ever done in math that is similar to multiplying matrices. Okay, so first of all, we're going to check to see if we can multiply these. The first matrix has 2 rows and 2 columns, so it's a 2 by 2. The second matrix has 2 rows and 2 columns, so it's a 2 by 2. So we're looking to see if the inside dimensions are the same. We only do that when we multiply. Okay, so we're going to start with our first row in our first matrix times our first column in our second matrix. So I'm going to try to write this out here. So we're going to do 0 times 6 plus 2 times 3. So that's going to give us 0 plus 6. And then I'm going to put that in parentheses because I know I have to combine that down to one number. Then I'm going to move from my first row. Okay, I've already multiplied first row times the first column. Now I've got to multiply first row times the second column. So that's going to be 0 times negative 6 plus 2 times 0. So it's going to be 0 plus 0. And as long as I'm multiplying by this first row, if you'll notice, I'm writing all of my work in the first row of my answer. All right, now I'm going to move down to the second row. So when I'm multiplying with my second row, I'm going to be writing my answers in my second row of my answer. So it's going to be second row times first column. That's going to be negative 2 times 6, which is negative 12, plus, because that's what the formula says, negative 5 times 3, which is negative 15. Then we're going to do second row times second column. That's going to be negative 2 times negative 6, which is 12, plus negative 5 times 0, which is 0. And then we'll simplify. And that's going to give me 0 plus 6 is 6, 0 plus 0 is 0, negative 12 plus negative 15 is negative 27, 12 plus 0 is 12. And that would be my answer. Rows times columns, rows times columns, rows times columns. Let's do another one. This one is, okay. So I'm starting off with 2 by 2s times 2 by 2s just because I think those are a little bit easier, and then I think I'll get harder from here. Sometimes I forget what I made in my PowerPoint. So as long as those inside dimensions are the same, it is possible. Okay, so we'll start with our first row. Always our first row times our first column. So it's going to be negative 5 times negative 2, which is 10, plus negative 5 times 3, which is negative 15. And then I'm writing my answers in my first row because I'm multiplying by my first row. Then I'm going to do first row times second column. That's going to be negative 5 times negative 3, which is positive 15, plus negative 5 times positive 5, which is negative 25. Then I'm going to move down to my second row. Now I'll be writing my answers in my second row because I'm multiplying by my second row. So I'll do second row times first column. That's going to be negative 1 times negative 2, which is positive 2, plus 2 times 3 is 6. Then second row times second column. That's going to be negative 1 times negative 3, which is positive 3, plus 2 times 5 is 10. And then I'll simplify. So that's going to give me negative 15. 15 plus negative 25. I got ahead of myself. 10 plus negative 15 is negative 5. I wrote the right thing and said the wrong thing. 15 plus negative 25 is not negative 15. It's negative 10. Yeah, 2 plus 6 is 8. 3 plus 10 is 13. And I would always suggest that you look for careless mistakes. So if I were doing this on a test, I would probably go back and check all my work, all my numbers. I like to place my fingers, like if I had this on a piece of paper, I might be touching, if -1 was getting multiplied by -2, I might have my fingers there, and then 2 times 3. Sometimes it helps me because I'll lose my place. All right. All right, this one's a little bit bigger, so we'll have more numbers here. This is a 2 by 3. Let's just make sure it's possible. And this is a 2 by 3. So again, as long as these inside dimensions are the same. We don't have to have the same exact dimension. So this, oh no, this one's not going to be possible. This is 2 by 3. And this is 2 by 3. So these inside dimensions are not the same. So we could add and subtract these two matrices, but we cannot multiply them. So this one's not possible. And if you don't write down the dimensions to begin with, and you just start going, okay, I got to know I've got to multiply the first row in the first matrix times the first column in the second matrix. You don't have enough numbers here. So there's 3 numbers in this first row, but there are only 2 numbers in this first column. So that's another way that you're going to know it's not possible. Or you can write the dimensions down. So the inside dimensions have to be the same in order for you to be able to multiply them. If they asked you to add or subtract these two matrices, then you could do that all day long, but you can't multiply them. All right, let's take a look at this one. This one is 3 rows, 2 columns. And this one's 2 rows, 2 columns. So I should be able to multiply these because the 2 inside dimensions are the same. Okay. So I'm going to start with my first row times my first column. Always first row in the first matrix times the first column in the second matrix. So that's going to be 0 times -4, which is 0, plus 5 times -2, which is -10. Then I move on to the next column. First row times second column is going to be 0 times 4, which is 0, plus 5 times -4, which is -20. And then I don't have any more columns, so then I move on to the next row. So second row times first column is going to be -3 times -4, which is +12, plus 1 times -2 is -2. Second row times second column is going to be -3 times 4, which is -12, plus 1 times -4 is -4. Move on to my third row. So third row, again, I'm multiplying with my third row, so I'm writing in the third row of my answer. When I was multiplying with my second row, I was writing in the second row of my answer. When I was multiplying with my first row, I was writing in the first row of my answer. So -5 times -4 is +20, plus 1 times -2 is -2. Third row times second column is -5 times 4, which is -20, plus 1 times -4 is -4. And then again, I like to just go back and double check. 0, -10, 0, -20, 12, -2, -12, -4, 20, -2, -20, -4, and then we just simplify everything that's in the parentheses. So we're going to get -10 and -20 in the first row of my answer. We're going to get 10 and -16 in the second row of our answer. And we're going to get 18 and -24 in the last row. And then let me just double check because we are human beings. And it is very easy to make a mistake. So there's my answer. All right, let's see what other examples we have. We just have one more. All right, now this one doesn't look so hard, but to me, and it may just be me, but when I don't have as many numbers in my matrix, it seems harder to me. So I put this one at the end because I really wanted you to get the pattern of how you multiply. So this first matrix has 3 rows and 1 column. And this matrix has 1 row and 2 columns. So again, as long as these two inside dimensions are the same, then it is possible. So I'm going to start with the first row. There's only one number in it, times the first column. So this is a lot of students, and I struggle with this also. So I'm not going to have any parentheses or any pluses because I don't have more than one pair of numbers to multiply. So when I do -5 times 3, I just get -15. And I don't do plus anything because that's 1 row times 1 column. When you multiply 1 row times 1 column, everything you get has to be added together. So if we go back to this one, when we multiply this first row times this first column, we get 0 times -4, and we get 5 times -2, and then those are going to have to combine because you had to multiply 2 pairs of numbers. So in this last example, I only have to multiply 1 pair, so I don't have to put a plus or a parentheses. All right, and then I do first row times second column. Again, that's just 1 pair of numbers that I'm multiplying, so I don't have any addition signs, no parentheses. -5 times -1 is +5. And then we move on to second row times the first column. 6 times 3 is 18. 6 times -1 is -6. And then we move on to that last row. Last row times third row times first column is going to give me 0. Third row times second column is going to give me 0. And then that's actually my answer. So -5 times 3 is -15. -5 times -1 is +5. 6 times 3 is 18. 6 times -1 is -6. 0 times 3 is 0. 0 times -1 is 0. So for some reason, even though I have a smaller set of numbers here, I think this one's harder because you're just doing, there's just one number in your row times one number in your column, and then you just get the answer. There's no plus sign there. There's not going to be a plus sign unless you have to multiply more than 1 pair. So 0 times -4 gave me 0. And then 5 times -2 gave me -10. And then those have to combine to give me that number. All right. Don't forget to, I'm going to send out the whiteboard that goes with this, the whiteboard link. So if you want to keep your whiteboard links for saving, you can. Totally up to you. So don't forget, if you're using your whiteboard, to download that. And again, this is lesson 8.04, Algebra 2, multiplying a matrix by another matrix. Have a great day.